Welcome to the podcast. Today, we're diving into the world of language models with a fascinating new development, the Diff Transformer. Joining us is Dr. Emily Carter, an expert in AI and machine learning. Emily, could you start by explaining what the Diff Transformer is all about?
Absolutely. The Diff Transformer is an innovative approach to language modeling that introduces a differential attention mechanism. This mechanism is designed to enhance how models pay attention to relevant context while filtering out the noise. Imagine trying to listen to a conversation in a crowded room. The Diff Transformer helps the model focus on the important voices, so to speak.
That sounds intriguing. How does this differential attention mechanism actually work?
Great question. The mechanism calculates attention scores by taking the difference between two softmax attention maps. This approach promotes what's known as sparse attention patterns. Essentially, it amplifies the important signals and reduces the influence of irrelevant ones, much like noise-canceling headphones that filter out background noise to let you hear the music clearly.
And what kind of performance improvements are we seeing with the Diff Transformer?
The Diff Transformer is quite impressive. It outperforms traditional transformers in several key areas: scaling, long context modeling, key information retrieval, hallucination mitigation, and in-context learning. For example, it can handle longer pieces of text more effectively, which is crucial for applications like summarizing lengthy documents or understanding complex narratives.
You mentioned hallucination mitigation. Can you explain what that means?
Sure. In the context of language models, hallucination refers to the generation of information that isn't present in the input data. The Diff Transformer's ability to focus on relevant context helps reduce these hallucinations, leading to more accurate and reliable outputs.
That's fascinating. But what challenges do traditional transformers face that the Diff Transformer addresses?
Traditional transformers often struggle with over-allocating attention to irrelevant context. This can make it difficult for them to retrieve key information effectively. The Diff Transformer's differential attention mechanism acts like a filter, canceling out the noise and honing in on the critical details.
It sounds like a game changer. What are some of the obstacles in implementing this new mechanism?
One of the main challenges is ensuring training stability and efficiency. Introducing new attention mechanisms can be complex, but the Diff Transformer uses multi-head differential attention and headwise normalization to maintain stability and efficiency during training.
And what broader implications does this have for language models?
The Diff Transformer can significantly advance large language models by providing a more robust architecture. It's less prone to distraction by irrelevant context, which means it can be more reliable in real-world applications like customer service chatbots or content generation tools.
Are there any interesting applications in business scenarios that you can share?
Absolutely. Businesses can leverage the Diff Transformer for more accurate sentiment analysis, better customer interaction through chatbots, and even in financial forecasting by analyzing long-term trends in textual data. Its ability to handle long context information is particularly valuable in these scenarios.
Looking ahead, what are the future directions for research in this area?
There's a lot of potential for further refining the differential attention mechanism and exploring its applications in other types of models. Researchers are also looking into how these techniques can be applied to other domains, such as image processing or even audio analysis. The future is bright for this line of work.
Thank you, Emily, for sharing these insights. It's been a pleasure having you on the show.
Thank you for having me. It's been great to discuss the exciting developments in language modeling.